Imagine pointing a telescope at a patch of sky and finding almost nothing. No galaxies, no clusters, just an ocean of darkness stretching 330 million light years across. This is the Boötes Void, one of the largest known emptiness in the observable universe. And its existence is one of the strangest puzzles in modern cosmology. Most people think of space as empty, but zoom out far enough and the universe actually has structure. Galaxies aren't scattered randomly. They're organized into a vast cosmic web of filaments and clusters. And between those filaments, enormous bubbles of almost nothing called cosmic voids. The Boötes Void is the most extreme example we've ever found. In this video, we're going to explore what it is, how big it really is, what's inside it, and what it teaches us about the architecture of everything. Before we can understand why the Boötes Void is so strange, we need to understand what the universe is supposed to look like at the largest scales. If you could somehow zoom out and see billions of light years at once, you wouldn't see galaxies sprinkled evenly like glitter. You'd see something that looks almost biological, a vast network of filaments, like the threads of a spider's web, with galaxies strung along them like dewdrops. Where filaments intersect, you get dense galaxy clusters, gravitational cities of thousands of galaxies. And between all of this, voids, enormous bubbles where almost nothing exists. These voids aren't small gaps. They typically span 100 to 300 million light years across, and they make up roughly 80% of the volume of the observable universe. So in a real sense, emptiness is the default. The galaxies, the stars, everything we think of as the universe, that's the exception. It's the foam clinging to the walls of a cosmic bathtub. In 1981, a team of astronomers, Robert Kirshner, Augustus Oehmler, Paul Schechter, and Stephen Schechtman, were conducting a redshift survey. They were measuring how fast galaxies in different directions were receding from us, building a three-dimensional map of our cosmic neighborhood. When they turned toward the constellation Boötes, they expected the usual scattering of galaxies. Instead, they found a hole, a region where galaxy after galaxy simply was not there. At first, they suspected a problem with the data. Maybe dust was blocking the view, or the survey had a gap, but follow-up observations confirmed it. There really was a region of space, centered roughly 700 million light-years from Earth, that was almost completely empty. The discovery was so unexpected it challenged existing assumptions about how evenly matter should be distributed. Nobody had predicted that the universe could carve out this much nothing in a single region. It immediately raised a question that cosmologists are still wrestling with. How does the universe build something this empty? A number like 330 million light-years is impossible to feel intuitively. So let's try to make it real. Our Milky Way galaxy is about 100,000 light-years across. That's already incomprehensibly large. Light itself needs 100,000 years to cross it. The Boötes Void could fit roughly 3,300 Milky Way galaxies laid side by side across its diameter. Or consider our local group, the Milky Way, Andromeda, and about 80 smaller galaxies spread across 10 million light-years of space. You could line up over 30 local groups across the Boötes Void and still not reach the other side. Here's another way to think about it. Light, the fastest thing in the universe, would take 330 million years to cross from one side of this void to the other. When that light started its journey, the most complex life on Earth was still in the oceans. Fish hadn't even evolved jaws yet. That's how long the crossing takes, at the speed of light. The Boötes Void isn't perfectly empty, but it's shockingly close. Surveys have identified roughly 60 galaxies inside the void. That might sound like a reasonable number until you do the math. Based on the average density of the universe, that same volume should contain around 2,000 galaxies. So the void holds only about 3% of the galaxies it should. And the galaxies that are there don't behave quite like normal galaxies. Many of them appear to be arranged along a thin, tube-like filament threading through the void, almost like a single highway crossing a desert with a handful of rest stops. Most of these galaxies are also what astronomers call blue galaxies. They're actively forming new stars at a high rate. In denser regions, galaxies tend to be older, redder, and more settled. The void galaxies are like frontier towns, young, active, and deeply isolated. Some researchers think the void's low-density environment means these galaxies have had fewer collisions and mergers with neighbors, so they've evolved more slowly. They're cosmic latecomers, still building themselves while the rest of the universe has moved on. To understand how the Boötes Void formed, we need to rewind to just after the Big Bang. In the very early universe, matter wasn't perfectly evenly distributed. There were tiny quantum fluctuations, regions slightly denser or slightly less dense than average. We can actually see the fingerprints of those fluctuations in the cosmic microwave background, the oldest light in the universe, released about 380,000 years after the Big Bang. Over billions of years, gravity did its work. Denser regions pulled in more matter, growing into the filaments and galaxy clusters we see today. Less dense regions lost matter to their surroundings, growing emptier and emptier. Think of it like rain falling on a landscape of hills and valleys. Water flows off the ridges and pools in the low ground. The ridges dry out. Voids are the ridges. Matter has been draining away from them for over 13 billion years. There's also a process called void merging. Smaller voids can grow together over time as the thin walls of matter between them erode and collapse, creating larger supervoids. Some cosmologists think the Boötes Void may have formed exactly this way, not as a single primordial bubble, but as a patchwork of smaller voids that gradually merged. Dark energy plays a role too. As the expansion of space accelerates, voids stretch open faster than surrounding structure can fill them in. The emptiness feeds on itself. Now let's run a thought experiment. Imagine you lived on a planet orbiting a star inside one of those 60 lonely galaxies in the Boötes Void. Within your own galaxy, the night sky would look fairly normal. You'd see your galaxy's stars, its nebulae, maybe a few small satellite galaxies nearby. But beyond that, almost nothing. From Earth, we can see the Andromeda Galaxy with the naked eye at about 2.5 million light-years away. Inside the Boötes Void, your nearest galactic neighbor might be over 100 million light-years distant, far too faint to see without very powerful telescopes. Here's the thought that keeps cosmologists up at night. And this is clearly speculation, but it's scientifically grounded. A civilization developing inside the Boötes Void might have spent most of its history believing its galaxy was the entire universe. Until they built instruments powerful enough to detect objects 100 million light-years away, they would have looked out and seen only darkness. Their cosmology would have started from a fundamentally different assumption than ours. We take billions of galaxies for granted. They would have had to discover that fact as a shocking, paradigm-shattering revelation. The Boötes Void isn't just a cosmic curiosity. It's a genuine test for our models of how the universe works. Our best cosmological simulations, run on some of the most powerful supercomputers on Earth, model how the universe evolved from those ancient density fluctuations into the cosmic web we observe today. These simulations predict that voids should exist, but they struggle to produce one as large and as empty as the Boötes Void. That tension is scientifically valuable. It might mean our simulations need higher resolution or better physics. It might mean we're missing something about how dark energy behaves in low-density environments. Or it could simply mean the Boötes Void is a statistical outlier, rare but not impossible, sitting at the far tail of the probability curve. Some researchers have proposed that voids might actually be ideal laboratories for studying dark energy. Because voids are dominated by dark energy rather than by gravity, they offer a cleaner environment for for measuring how cosmic expansion is accelerating. So, this enormous bubble of almost nothing might hold some of the most important clues about the ultimate fate of the universe. The emptiest place in the cosmos might have the most to teach us. So, the Boötes Void, 330 million light years of almost nothing, 60 lonely galaxies.